Okay, previously I gave an algebraic definition of the trig functions, and I gave that algebraic definition based off some geometry, but based off of a right triangle. Okay, but let's look at the definition of these trig ratios within maybe a larger geometric definition of these trig ratios. Okay, so first of all, notice that we have, triangle ABC, and vertex A is right on the point of 0, 0 on an x, y coordinate system. If you do this, then the hypotenuse of this right triangle, is also the radius of a circle. Let's do one more undo. Let's do that instead. Okay. And vertex B here is a coordinate that is on the intersection between the terminal side of an angle of interest and the circumference of the circle. And so that creates an XY ordered pair on this XY coordinate plane. And now what you want to do is finally draw a line through point B, which is on this intersection. Draw a line tangent to the circle, but through that point B, just like that. And you'll see that this tangent line intersects the x-axis, and it also intersects the y-axis, and it creates some separate line segments here and here. Okay. And so what are the consequences of setting this up this way? So one consequence is that the length of this line segment, the length of this side of the right triangle, is equal to the radius of the circle times cosine theta. And the x coordinate at this point is exactly this value, r cosine theta. So the x coordinate at this point is r cosine theta. And likewise, the y coordinate of this point, let's see here, the y coordinate at this point, if we were to trace on over to the y-axis, it would be r times sine theta. So just looking at the coordinates of this point will tell you something about the cosine of your angle of interest and the sine of your angle of interest. Okay. And finally, we drew this line tangent, this tangent line from point B down to the x-axis where it intersects the x-axis at point D. This is r times tangent. And if you remember, tangent is y over x. So this y value over this x value. And here I'm using, this letter r to represent the radius, but I think you can see that if the radius was equal to 1, right, this would be a 1, that would be a 1, and that would be a 1. and that would be a 1. And you just have the length of this side is cosine theta, the length of this side is sine theta, and the length of this segment is just tangent theta. Now, as this angle of interest changes, as it gets bigger or as it gets smaller, the lengths of these sides and even this tangent line are also going to change. And that's what we're going to see on the next page. So let's go to the next page, where I've got some of these angles already set up. Okay, let me see here. Let me get rid of that. Kind of distracting. Okay. So when I show you these 3 examples, look at how cosine theta, sine theta, and tangent theta are changing in their lengths relative to the angle changing. So here we've got our angle of interest is 60 degrees. And you can see that the sine of that angle of interest is pretty tall compared to the cosine of that angle of interest is relatively short. So you can see that sine is greater than cosine. And what that means is that when we take the tangent of this angle of interest, right, tangent is sine over cosine, that because sine is higher, it's a greater number, the tangent's going to be greater than 1. So the length of this line segment will be greater than the radius. All right, let's come down to another example. So we just had 60 degrees. Now what happens when the angle drops to 45 degrees? So what you'll notice is that when our angle of interest is 45 degrees, the length of sine theta is equal to the length of cosine theta. Cosine and sine lengths are equal. And because they're equal, tangent of this 45 degrees is going to be equal to 1. So the tangent will be equal to 1. And notice that when the tangent is equal to 1, it's the same length as the radius. And then if we look at theta getting even smaller, so at 30 degrees, so here our angle of interest is 30 degrees. And now you can see that sine theta is getting shorter, but cosine theta is getting larger. And since sine theta is going down, the value of tangent is going down. And so the length of this segment on this tangent line will be less than our radius. All right, so that is just a brief introduction to this geometrical relationship between these 3 different trig functions. And I'm going to put the other 3 in here also, so you'll see this picture again. But this idea, of x being equal to cosine theta and y being equal to sine theta will come into play here shortly. Okay, so I think this is a good place to stop things. Let me know if you have any questions.